Good afternoon, everyone. Please welcome our next speaker to the stage, Senior Director of Product Intelligence, Exiger. Did I say that right? Exiger?
Exiger.
Exiger, yes, Exiger. Griffin Fletcher, everyone.
Thank you so much. Good afternoon, everyone. Griffin Fletcher, work on the product intelligence team here at Exiger, where we help some of the largest governments, private sector organizations to understand their supply chain risk, both in the hardware components that are nested under the hood in the products that they make and the products that they buy, as well as the software that is under the hood inside of all of those products. Just recently got back from Gartner Supply Chain here on Tuesday, where I tried walking down the line to see how many booths I could walk by without seeing the words agentic or AI. And I made it by 2 booths and tried many different ways. So everything that we're discussing here in this room, finding its way into supply chain here at Exiger, we're leveraging that technology to help our customers really understand what's underneath the hood inside of their supply chains. Whether this is a Ford F-150 or an F-35, whether it is the latest iOS update or Exiger software itself, we are dependent on organizations outside of the 4 walls where things are ultimately manufactured. Here at Exiger, we are leaning in, adopting a AI product development lifecycle, really eating our own dog food, making it such that we can go and have a conversation with a individual on a Tuesday, and by Friday we've already deployed that feature, we've already built that new widget, that new workflow into the platform. And really key in the way that we approach supply chain mapping is an understanding it's not just where a particular component is made, but ultimately who is manufacturing that component. We may know that we have germanium and gallium nested inside of that supply chain for the F-35. We may think we have an allied source in Germany, but that German refinery of that gallium is ultimately fully owned by the CCP. So it's not only where particular components are manufactured, but who is manufacturing them and transforming those particular processes. Supply chain is a complicated problem. It extends beyond procurement and logistics professionals to the engineering teams that are designing the components, the weapon systems, the products that we're ultimately consuming. Many different questions ranging from what is the impact of the closure of the Strait of Hormuz, what is the impact of rising oil prices, where is antimony or our heavy rare earths across all of the programs that we're ultimately responsible for, and increasingly, what can we do about it? What are the alternate suppliers? Do we own the design data so that we can swap out a particular component? And often when we see that antimony restriction come out of China back in September of 24, procurement points the finger over at engineering, saying, where is this across all of our products? And engineering points that finger right back. It's a web of different stakeholders that are ultimately intertwined to answer these supply chain problems. It's the title of the session here today, really in the way that Exiger approaches supply chain risk, supply chain mapping. Folks often think of supply chains as a pyramid, widening out as you go down through the different tiers in the supply chain, ultimately down to the raw materials. Really key in the way that we approach supply chain risk is in understanding it constrains itself at various diamonds inside of that pyramid, whether it's lithium hexafluorophosphate salt that's used in all of the lithium-ion batteries that are powering the drones behind us, the neodymium magnets that are in all of the robotics, just a few over to the left. There are certain concentration points inside of those supply chains that is really the end to which supply chain mapping is occurring. It's not just that we often hear, I want to map everything down to the hole in the ground all the time. I want to know where everything comes from. But it's really mapping is a means to an end to understand where those choke points are inside of those supply chains. Where do we have the ends of those diamonds? And key to that is really understanding the criticality and the viability of each of the components that are manufactured. A single source bearing supplier that's used in a particular weapon system, if that supplier has a large factory fire, that represents a very different risk than a multi-source paper towel supplier that ultimately isn't critical to those particular programs. When we're building out these supply chains, a complicated web of different data sources, we're leveraging shipping data, commerce data, trucking data. We're looking to see, did TSMC announce in their 10K that they're excited to be producing a new 20 nanometer facility, and by necessity it has to flow through that particular fab. Much in the same way that we leverage NLP to understand the risks of an individual company, who are they doing business with, we're leveraging that to map supply chain relationships. Did a company announce that they're excited to be supporting a new program? They're excited to be working with a new partner on a particular program. We leverage NLP to surface those insights on those supply chain relationships. We'll go out and do logo identification on company websites. But really key to understanding supply chain risk is the part intelligence. What is the actual item itself that I'm consuming from a particular supplier? We're used today, Exiger's capabilities, as the first stage in the funnel for all new parts that are added both to FLIS and to GSA Advantage. So when a DLA cataloger in Battle Creek, Michigan is loading a new F-22 part, they leverage Exiger to see, have we seen this part before? Maybe it's a different supplier, a different part number, a different description, but it's ultimately a form, fit, function alternate for a part that's already been cataloged. You need to go out to an array of different commercial catalogs. What is Avnet, Farnell, Grainger saying about these particular components? And you need to understand them with their ontologies and references. We might see that a part listed on a catalog references ASTM B271. We're doing those steps and inference to know that's a copper centrifugal sand casting with 2% antimony that's ultimately trade restricted and embargoed out of China. So understanding how it's contextualized with UNS numbers, HS codes, helps us to better map the supply chain and understand what components are most critical and least viable, the ones that we ultimately need to focus on the most. And we've been doing this for well over 20 years, an understanding of known manufacturers, so that when a supplier has that factory fire, we can reach out to say who else has made similar parts and sold them to the government and could be a viable alternate, even if they're not qualified today. Data is often siloed and in varying degrees of product technical depth. In many cases, folks have hundreds of thousands of engineering documents, millions of engineering technical data packages that inform what they're ultimately being tasked out with supporting and procuring. On the other side, a number of black box items. All that we know is a supplier's name, a product description, we may have a part number. Different capabilities need to be leveraged to bring in the data to be able to map out that supply chain. Somewhere in the middle, we may have NINs and NSNs and DOE particular catalogs. Bringing together all of those data sources, we meet our customers where they and their data are to build out that supply chain. We'll ingest the technical data packages, preferably bidirectionally into the PLM system. That problem earlier of the antimony part, we designed that part with antimony, knowing that we had the reliance on China for that particular component. We designed it with that single source dependency. So to the extent that we can push that back into engineering and those insights of the supply chain, we use the technical data packages, the hardware bills of material, and those part descriptions ultimately to analyze inside of our knowledge graph and identify the most high-risk relationships and value chains, where we can then see where is antimony, gallium, germanium across all of the programs that I'm responsible for. Where do we think that we have multi-source at tier 1, but it's ultimately single source constrained there at tier 2, hidden just under the hood across multiple programs. China's weaponization of the periodic table, many speakers today have talked about the extent to which China has leverage in certain critical minerals. It wasn't an accident, very intentional to work back to the raw material processing, those difficult processes that we ultimately don't have the manufacturing or industrial base here in the United States. Gallium, germanium, antimony. When antimony restrictions were initially announced, DLA inside of their data set was able to see about 500 parts that contained antimony. When we look at the same data set, leveraging those inferences in manufacturing processes, we see over 11,000. That 20x difference is really, where is it not clearly listed in the material description, but it's nested in those specs and standards, 2% antimony for hardening of that particular alloy. Increasing restrictions on samarium, cobalt magnets, dysprosium, terbium, other components that are used to dope those particular magnets to function at high temperatures. New restrictions announced May 1st, just a couple of days ago, on sulfuric acid. Some of these are intentional to constrain our defense industrial base. In the case of sulfuric acid, they need to be able to feed their own population. It's used as a critical component inside of fertilizer. So very intentional and unintentional uses of those restrictions that ultimately cut us off at the knees. Had mentioned there a large specialty fastener manufacturer just north of Philadelphia, SPS Technologies, large history of EPA violations, OSHA violations, ITAR violations going back over the past 5 years, really showing us the smoke before the fire itself as they had that fire back in February of last year. It's not just enough to know that they make specialty fasteners. We see inside of our data 3,500 single source bearings that are ultimately leveraged in critical applications and inside of critical weapon systems. In many cases, we do have the technical data package. We received 80 different drawings that were leveraged on the Bradley fighting vehicle. Inside of those drawings, there was a part on a wiring harness that was long lead times. The customer didn't ultimately know why that part was delayed, what was driving those long lead times. We analyzed those inside of our vision model, paired with our knowledge graph to see there's actually 3 copper castings inside of that wiring harness where it connects back to the vehicle itself. One of those was obsolete. That information never left the casting house, back up to the wiring harness manufacturer, back up to the vehicle manufacturer. And it's not just enough to identify what that obsolete component is, going the next step to say, who else has produced similar copper centrifugal sand castings, cadmium plated over the past 20 years that could be a viable alternate for that part that's ultimately obsolete. All of the drones that are buzzing behind our heads, we've done extensive work in mapping UAS supply chains to identify critical vulnerabilities. We're designing these systems with the supply chain in mind. We have the benefit that we're not sustaining 40-year Spy-1 radars and trying to extend the life across those particular systems. We have the benefit of designing with those choke points in mind. Exiger would receive an input as tell me everything about lithium-ion batteries that are leveraged in UAS applications. It's not just enough to identify we have a constraint on lithium hexafluorophosphate salt. There are no US producers of lithium hexafluorophosphate salt. We have to turn to Japan, to China, to India, or to South Korea to procure this critical ingredient. All of those that we see there on the top right, the cathode, the anode, the LiPF6 salt, we can't produce a battery without them. But as we start to look through the lens of criticality and viability, it's looking to see we don't have that domestic supply chain for the LiPF6 salt. What are the different recommendations that we can generate outside of a RAG model, incorporating customer internal policies, memos, and documentation so that it's tailored to the levers that they can actually manipulate to bring that LiPF6 salt back into the US and increase that industrial capacity. The same problem emerges inside of rotors and magnets leveraged on all of the full robots that we see there to the left, all of the different drones heavily dependent on neodymium and particularly samarium cobalt. The fasteners, the adhesives, all of them are critical. We can't have a motor without them, but it's looking in to see which ones do we not have the viability to produce, where can we stand up manufacturing capability here in the US, and where are those particular courses of action. We've talked a lot on really the high risk viability constraints that we look at inside of these supply chains. We can be inundated with disruptions and risks and news articles, everything that's coalescing all at once and disrupting our supply chains. It's important to capture all of that data, but to really focus in on what is the actual viability of a mitigation to address that vulnerability. If we want a mine-to-magnet supply chain here in the United States, investments like Vulcan, like in MP Materials are helping us get there, but those are 5 to 10 year time horizons for us to be able to stand up that full supply chain here in the US. Swapping out that SPS fastener, we may have an alternate already available. It's high risk, it's impacting multiple programs, but we have the supply chain, we have the industrial base to stand up those capabilities here inside of the United States. I think we'll have a few moments for questions, but want to pause as well and note Exiger is just outside of the booth as you walk out of the door. We're going to be conducting a large demonstration on the front screen to actually walk through how we're identifying all of these supply chain vulnerabilities at scale across some of the largest organizations, both government and public sector. Any questions here from the room?
Does anyone have any questions? If you could just raise your hand if you have any questions. No one? He doesn't bite, promise. Okay, well, thank you so much, Mr. Griffin Fletcher, everyone.
Right across the way.